Okay, now let's run naive Bayes using the naive Bayes procedure in E1071 library. So we'll capture the results in delays NB. Okay, and then naive Bayes, and you see it comes from the library E1071. Okay, now you have to specify the formula. Okay, and here we have to specify the target as a factor. So this is train.df flight status, right? So that's the target, and that has to be a factor. Okay. And we want that to be the target and everything else. So we put a tilde and the dot. So that means all other variables will have to be used as predictor variables. Okay, and then you specify the data. So the data will have to come from train.df. Okay, and we then print delays.nb. Run these two lines of code. Okay, so now you see it gives you conditional probabilities for all the predictor variables. Okay, well, that's good, but how do you use those conditional probabilities in coming up with prediction? Okay, and for that we have to use predict. So we can predict the probability or predict the class, either one. So when you use type equal to raw, it will generate the propensities probabilities. If you set type equal to class, then the predicted class will be generated. So let's do both. So we say pred prob, predicted probability. We use predict, right? And we use delays NB. That's where the model results are stored, right? And then you specify the source data. So new data is valid.df. Okay, and then you can say type equal to raw within quotation marks. Okay, and then you run that. Then you get predicted probabilities. Okay, they're all here. Okay, so you have probability for delayed and probability for on time. Okay, we do the same thing. So let me copy paste this line and change two things. Change the name to pred.class, right? And instead of raw, we say class. Okay, when you do that, then you have pred class. Okay, so for each observation in valid, you have the class that if you want to view that, you need to do view, okay, to uppercase V. Okay, and pred.class. Okay, so here you see, so on time, and some delayed somewhere. I think so. Here there is a delayed, and so on. So these are the predicted classes. Okay, suppose we want to extract a particular set of flights from the validate data set and look at what the probabilities are for those flights. Okay, let's assemble these values into a data frame. So we'll call it valid pred.df, right? And we'll make that into a data frame. Okay, and data frame, we give the name of the column and the values that go in it. So the first one, let's assemble the actual flight status, right? So we call it actual equal to valid.df flight status. Okay, so that'll be our first column. And then we'll call predicted equal to, so we have the predicted class right here. So that will be equal to pred.class. So predicted will be the name of the column and the values in the column will be that. And then we will just simply say the predicted probability. So predicted probability, remember, has two columns. So both columns will be included. Okay. And since we are not specifying any name for the column, okay, the column names from the source data set will be used. So if you run this, okay, now if you look at the valid.pred. So you have the actual, predicted, and then the probabilities for each of the row. Okay, then we can extract a particular. I mean, for a sequence. No, if you want to look at a certain set of flights with some characteristics, and you want to look at what the predicted values are in the valid data set, then we can use this code. So you go to valid pred.df. You want to extract from this, okay, all the rows that satisfy a particular set of conditions, and then you want all the columns in there. There are 4 columns, so we're going to put a comma, so nothing on the right, so which means all the columns will be included in the output. And here we give a condition. Okay, suppose we want all the flights, all the delta flights, right? So then we can say valid.df, okay, carrier. Okay, and you want to check whether the carrier is delta. So since you're comparing, you're not setting the value, but you're checking the value, you have to do double equal sign, and then you say DL. Okay, so that will be all the delta files. Okay, now if you want more conditions, if this is the condition you want and that's it, then you just press enter. Okay, but if you have more conditions, then you can tag along those additional conditions with ampersand sign. Okay, so we want all the carriers that are delta, and say you want day of the week is 7. Okay, so again you do valid df day week. Again we have to compare, you're checking the value, so that should be like that. Okay, the reason why we have to put it within quotation mark is because this has been changed to a factor. All right, not comma. And then if you want some more conditions, for example, your textbook wants you to look at departure time of 2 p.m. So that's 14. So again, valid.df departure okay, so we have scheduled departure time equal, and we want to check equal to 14. Again, we have to do this and then we want do ampersand. We want destination LaGuardia. Okay, destination check LGA. Okay, ampersand origin DCA. Okay. Okay, for the purpose of being able to reproduce the same results, I should have set seed up here when we did the partition, which I forgot to do. So let's go ahead and do that. Okay, let's set seed to 1, which means now we have to run these lines of code again. So I'm going to clear this. Now let's go ahead and run that set. Okay, so now if you run the tables for proportions, okay, so you should get these, and then we run the naive Bayes, okay, and we do the predicted probability, predicted class, and then we assemble them into that data frame. Okay, so now if you want to extract all the flights that satisfy some condition, then so here for example this one, all right, so we run that line of code. So we have carrier equal to DL, day of week is 7, departure time is 14. It turns out that you can use within quotation mark or outside of it destination and then origin and then comma everything else. So we have one flight that satisfies those conditions. So suppose if I go and change, say weekday day week is 5, and if you run that also gives me 1, and maybe if I change the time to say 18, and I get 3 flights. And each of those cases, since we are getting the row number from the valid.df, but we are outputting rows from the data frame that we assembled, the actual flight status, predicted flight status, and the probabilities. Now if you want to score the new set of flights, then you have to build a data frame of all the new flights and then run it through predict. So if you want to, we'll just do 1. Okay, so again we do predict. Okay, I'm not going to save it into anything, so we'll just use the procedure, and this will be delays.nb is the model, and now we specify the values for the variables, right? Okay, now we specify new data. New data is a data frame, and we have to specify the values of the new data for each of the predictor variables. So just to make sure that I don't make any typos, so column name, and we set it to a particular value. Okay, then comma the next column name, right? And okay, you need to change that to equal to 5. We are not checking here, we are setting the value, so you need to use a single equal sign, and then CRS time again a single equal sign, and then destination is LGA, comma, origin is DCA, I believe. Okay, DCA. All right. So that would be the 5 columns within converted into a data frame. Okay, and that would be used for new data. And then we have to specify type equal to raw for probability. Okay, so now we run this code and we get the probability for delayed and on time. Now if you use the same code and change the type to class, then that will give us the predicted class. So predicted class is online, on time, and the possible levels are delayed or on time. So our prediction is on time. Okay. Now we can generate the confusion matrix very simply because it comes from gains. So we use confusion matrix. It comes from caret. Sorry. So here we have to specify for confusion matrix a factor of predicted class and a factor of the actual class. So predicted class is for the valid data. We have okay, as factor. Okay, so we have predicted class right here. So pred class. All right, comma. Again, as factor the actual class. Actual class comes from valid.df flight status. Okay. I run that, and we get the output. So we have the confusion matrix, the accuracy, and all the other performance measures.